Have you ever, do you know like any scenario, or it could be just like a hypothetical scenario where you think the laws of, like the law of energy conservation might not hold? From, I think I can even retitle the stream to be that. He's saying that, do you think the laws can be broken? It means the laws of physics. And for him, I'm pretty sure it's more about the laws of, to do with thermodynamics, especially the principle of energy conservation. I think that is what is more about, I'm pretty sure. Do you think they can be broken?
No. So I'm really big on probability and statistics as well. So when you start weighing in how many times an event happens versus when it doesn't happen, there's never been a known exception for some of these laws. That's why they're laws, because there's no known exception to that rule or that law. So if there is an exception, we would have to rip up everything we have. Now, the odds of that happening, slim to none, slim to none. So I'm not. I'm extremely confident that the laws are not. These are laws of nature. These aren't laws of man. These are laws of nature. Don't forget. This is not something man made up. The models replicate real world events. And if it never had an exception in any Earth time that we know of, why
Yeah.
would we expect it to be anything else? So that's why I depend on the mathematical models, because I know it's dependent on empirical data. So it's not a guess. It's not a, well, maybe, maybe not. No, that's probability and statistics. But usually that event happens every now and again. But when you're talking about something that never, ever, 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 ever has happened in history of man, I'm confident it's not going to be broken.
Maybe it could be like our understanding of the some certain laws could change over time.
What's been happening though over time? We
Yeah.
get better with the models. So usually you start out with like a crude model. It's not great, but it's accurate enough to explain the natural phenomena. And then someone comes around, perfect example, Isaac Newton, his for his equations, F equals ma, all the force equations, like they still stand, but we got so good at the model, we learned the rules change a little bit when you talk about motion. When you talk about extreme speeds like speed of light, when you're talking about relative speeds and the size of a mass, that can change. Newton's laws work great. Einstein came around and said, "Wait a minute. If we have this kind of scenario with a large mass or a small
Yeah.
mass and fast speed of light, all these things, Newton's laws break down. They no longer are as accurate as they were in his time. That's because we got better models now. But if you limit the speed of things and the size of things, you revert back to Newton's laws and they work again. That doesn't mean he was wrong. That just means the model was not as refined as Newton. I mean, as Einstein. That's all. Are we going to get better than Einstein? Probably. Probably. Over time, I think, like over time, you learn, you get more data, more information, the models become better. But up to this point, there's no known exception to the laws that we have. Not one. Not one. Even all this talk about dark matter and this, there's changes in the properties once you scale down to like nanoscale and once like atomic scale. Yeah, the physics don't hold as it would at our level, you and I. But okay, it's different if you scale down. Same thing if you scale up. The rules are different, but there are laws that are not broken. They're still maintained, regardless of scaling. So odds of breaking those, I doubt it.
You don't think that it will ever happen?
No, no, no. As far as what we are, like the capability in my lifetime, probably in our children's lifetime, no, No, it takes a while to really just fully understand what we have and refine the models and all of that stuff. But to break them, that's a whole different thing. Usually, it ends up being like an addition to. It ends up being an add-on. Like again, I'll use the Einstein example. His is more of a limit. His mathematical models answers the call where Newton's fail because Newton's didn't include uh, it has a size limitation and a speed limitation for those models. Are they good models? Yeah, they're just not as accurate when you go too fast, right? Like there's limits. I feel like we're just getting better, but there are still fundamental laws that has not been broken. They have not been broken, and I doubt we're just going to wake up tomorrow and just break a law. It, I don't see that happening at all.
Let me show you. I wanted to show you this paper I'd seen. Where they say that there's something which generates more. He's asking, so not over unit. What about zero loss?
Zero, like oh, zero loss. Um, we can get really close. We can get really close. At extremely low temperatures, we can get near zero loss. But
Hmm?
absolute zero, no. That's actually a theoretical. That's a theory, not even a scientific theory. That's a theory. Like what happens at zero? Like we can get close. Let's put it that way. Up to this point, we've gotten close to zero loss. And if you're talking about machines, if you're talking about systems, you're talking about 100% efficiency. Um, and no, no, because we don't know any system that doesn't take loss when either converting, transitioning. We're talking about energy earlier. When you take energy and you convert it, whether you convert
Yeah.
it from wind to electrical or solar to electrical or electrical to mechanical, back to electrical, all the conversions will cost you. They just will cost you. There's a loss. There's usually in the form of heat. Um, can we get better models, better, more efficiency? Yes, when we start learning how to manipulate different materials. We're learning that stuff now. I like that battery one you put out too, though. That was a good one. Because if that actually is on the forefront, I've been
Hmm.
saying that on the channel, on Q-Butter's channel. I've been saying that for a long time. The day we change that battery, we can change a lot of things on how we do it. Because the battery's been the same for quite a while now. Um, and we have other versions of, like, we went from alkaline to other types like cadmium, lithium, trying different materials. Are there better materials out there? Probably. We just didn't get to them yet. But somebody's out there looking at it.
According to what you know so far in terms of physics and all that, like, do you know like any scenario, or it could be just like a hypothetical scenario where you think the law of energy conservation might not hold?
Um, because I know, like, we've never seen an electron, but we know an electron exists.
Yeah.
Meaning we can literally count charge carriers like through a medium. Like we have tools that can count them, right? But
Yeah.
they're not created. They're generated from a material that already has them. So if you're passing more charge carriers or inducing a current through magnetism, doesn't matter. They're not being created on the fly. Like um I don't want to get too much into the physics because it gets a little weird, but there's nothing that's created. It's already in existence, and we're just manipulating what's there. If you're
Yeah.
talking metal, if you're talking semiconductor, if you're talking resistor, whatever the material, it has matter. And if it has matter and it has let's atoms, splitting atoms takes energy. All these things we can do to manipulate the material, but the material is the material. There is no creating more. You have to start with something in order to generate something else, but you can't create it. It doesn't come out of nowhere. That's not even a thing that's ever been witnessed. So to say we're going to get more out than we put in, that means something's getting created. And that's why it's a fundamental breaking of that law. You can't create anything. It's either there or it's not. And we can manipulate it, but that's it. We can't create it. So I don't even see how it's possible unless, again, if you're the first person to ever do this in human history, to create energy, create it. Sometimes people don't even know it's there. Some people don't know it's there, so they think that it's being created. No, it's there. The energy's there. It's in potential energy. A kernel of popcorn, the energy's already in the kernel. You just raise the temperature high enough to release it. Does that mean like popcorn kernels are unlimited? No, because once they pop, that's it.